Okay, yeah, so good morning again. Welcome to our next big data class. This will be the last class that goes over any material that would be on the midterm. And I'm hoping today is going to be both an easy class and a productive class. We're basically just going to go over some of the problems in the homework assignments, and not really new techniques necessarily that this homework assignment has inside of it compared to, say, pagala-hw3, but they are sort of maybe weirder or different in different ways, and so we'll take a look at that and solve some of the problems in a couple different ways, just building up more of our comfort with SQL. Last time we had, well, it was an exciting class because of Zoom failures and things like that. So I did post on the issues on GitHub an alternative link to a lecture from last year that was recorded over Zoom and covers basically the same material. So that would probably be the better thing to review from. But one of the things that we were talking about was the different sort of architectures of tables, how they can relate to each other. And in particular, the one that's going to be the important one for today is this idea of a many relationship. And the simplest example that we have in our Pagala database of that is the relationship between the film and the actors. That one film can have many actors inside of it, probably does. And one actor can be inside of, or can act in many different films, and they probably do. And that the way that we represented that relationship is that, so again, the stars in this table represent primary keys. A primary key is just something that is not null and unique. So there's only one actor ID, and every actor must have an actor ID. And then these lines represent foreign keys. So they're the actor ID that's inside of the film actor table must exist inside of the actor table over here. These symbols at the end of the lines, they turn out for whatever reason not to be correct in this diagram. The lines themselves, they can be automatically drawn, and so the lines in these diagrams are always correct. But the symbols are basically like comments, and so machines can't really generate them for various reasons, and so they often are incorrect, and I basically always ignore them. But here the actor ID, foreign key references this actor ID right here, meaning anytime we have an actor ID in the film actor table, it's guaranteed to be in the actor table. And then this film ID right here, guaranteed to exist in the film table. And so this intermediate table, this film actor table, is what connects the actor and the film table, sort of making it look like a bipartite graph and giving us this many relationship right here. So talking in particular about these three tables and this many relationship, because today we're gonna talk about problem number 6 in the homework, which will exploit that many relationships. See what a SQL query looks like on these many relationships. And again, there's no new syntax or things like that we're going to talk about today, but you'll see how the SQL things that we've talked about already apply to this situation. Before we actually get into doing the code for that, any questions about anything? Okay. So again, this problem that's opened up right here is on the Pagala homework 3. This homework assignment is due not this coming Sunday, but a week from Sunday. This Sunday is the Pagala homework 2 assignment. And again, this sort of material is related to the outer joins and the subqueries, things like that. So it might help you review or help you better understand what's going on in the pagala-hw3, but it's really part of the homework 3. Are we ready? All good? Okay, some thumbs up. Okay, so the idea of this assignment is that, or it's inspired by the idea of the Bacon number. So there's this game, 6 Degrees of Kevin Bacon, famous actor, and has been in a lot of movies with a lot of different other famous actors. And if you pick 2 actors, you can come up with like a chain of movies and other actors that, so actor 1's been in a movie with actor 2, actor 2's been in a movie with actor 3, and finally actor 3's been in a movie with Kevin Bacon. And in our data set, we don't have Kevin Bacon because it's all made up, but we do have this guy, Russell Bacall. And so we're going to be calculating the Bacall numbers, playing the 6 degrees of Russell Bacall with our SQL queries. And in particular, this problem's asking us to list all the actors with a Bacall number of 1. So that is, list all the actors that have appeared in a film with Russell Bacall. Coming back over here, this film actor table right here is what encodes the sort of information about what actors and what go in what films and what films go with what actors. Let's come up here, pSQL. Oh, no container found for pSQL here. Let's do a Docker PS. We haven't done this in a while, but I'm going to clean up all of my Docker containers here. So if you remember, I did a Docker PS-Q a long time ago. What that does is it just prints out the container IDs, all of these numbers right here, the container IDs corresponding to these up here. And I can do Docker RM. I could copy and paste these numbers, but that's sort of a pain in the butt. So I'll let the shell do that for me automatically. Docker PS-Q like that. I cannot remove something that is still running, so I needed to do stop first. There we go. And now if I did Docker PS-Q, nothing comes up. But if I do QA, because the A lists all of them, then not just the running ones, then I still have things running, or I still have things stopped that exist. So now we can do Docker RM, Docker PS-QA, and that'll actually delete them all. There we go, nothing's running. So I can do Docker compose up -d here, bring the homework problem up, and then Control R, pSQL, there we go. And now we're ready to actually get to work on this problem down here. So there's, let's get a little bit more room here. A lot of different workflows that we've used on these different problems before. The workflow that I'm going to use, that's no number this time, is I'll type my SQL queries down here in this Vim window on the bottom, and then copy and paste things into the top window as we're ready. So the first thing that I want to do is, so let's see. Let's go ahead and take a look at what the expected output of this, so that I know what the what kind of columns I should have in my select statement. So let's do tab E, then there's this expected and 06 dot out like this, and here is the actor name with just as a single column, first name space last name. 111 rows. Oops. And so I'll do a select first name space last name as actor name like this, and we'll start off with just a from actor. That actor is the table that has this information inside of it. Let's go ahead and copy that up here, hit enter. And there we go. So we're getting some results, but it's all the results now. We haven't done any of this filtering. So this is people with Bacall number 1, 2, 3, 4, 5, all the different numbers possible. One other thing though, I'll go ahead and do, since we were just looking at this, things are ordered alphabetically over here. So let's go ahead and add an order by clause, order by actor name down here. So we haven't really done anything interesting yet, just making sure that the output's going to be in the right format. Any questions so far? Okay, so now that we have this, let's get all of the films that all of these actors have appeared in. And so join film actor using actor ID. Again, the reason I need to do this is because over here, the film actor table is what connects the actor and the film tables down here, and the actor ID is the common column that they both have. Save that up here. And now we get, so Adam Grant is there a lot, Adam Hopper's there a lot, because presumably they're in a lot of films. We can just double check that real quick, add a film ID column up here so that we can see what all films they're in. And yep, there's all the film IDs, and there's all the actor names over there, lots of different films. And what I want to do is, or what I need to know next, is sort of something totally different than what I have down here. That this is sort of going to be the base of my final query. But what I'm going to, we'll pause this for a second and think about Russell Bacall in particular for a little bit. And so I'm going to make another query down here and just figure out what are the actual films that Russell Bacall has been in. So we'll do a select film ID from, let's see, we'll do it from film actor. And then I need to know what Russell Bacall's actual actor ID is in order to get the films that he's been in. There's two ways that you might want to do this. So basically what I want is where actor ID equals Russell Bacall's actor ID. There's two ways that I might think about doing this. Maybe the most naive way is up here I can do a select actor ID from actor where first name, actually, and we'll just do it like this. We'll just do a select star from actor, even simpler. And now we have all this information up here, and I can search for Russell Bacall right here. He's actor ID number 112. And so I could hard code this information, 112, like this. And then this query right here will give me all the films that Russell Bacall is in. This is sort of a tempting workflow to go through at times of using one query to find an answer and then hard code the answer into your query down here. I recommend not doing that though, because it makes your queries sort of not very flexible, that if I ever wanted to change Russell Bacall's, maybe we want to play the game with a different person other than Russell Bacall. And it's not really clear, if I'm having to debug this later, where this 112 came from. So a better thing to do would be to actually make this a little bit more systematic, where we just have one query that does the whole thing for us. So we'll join on the actor table using actor ID, and then the where clause down here will be where first name equals Russell and last name equals Bacall, like that. And if I do that, hopefully this should give me the same 112 number, or it'll give me that same list of film IDs that we had before. There were 25 before, still 25, that's good, because those are the films that Russell's been in. This, this doesn't look too nice down here. So one of the things that I commonly do when I'm formatting my where clauses is format them like this, where the joining operators, your conjunctions, disjunctions, ands, ors, nots, all those things get lined up so that the column names all are in line with each other, and the ands and ors just take up this white space over here. I think that's a little bit more readable. And so now we have two different select statements that are related to what we want to do. This one up here, giving us all the actors and their film IDs. And what we wanted to do is we want to filter and only get the rows in here that correspond to film IDs that actually have Russell Bacall in them. And that's what the purpose of this query down here was. That this query gives us those film IDs, the film IDs that Russell Bacall was actually in. So one thing we can do, we can add a where clause up here, where film ID is in, and then use this whole thing down here as a subquery. That, we'll indent it, make it nicer, delete the semicolon, and try that out. And so now we have, yeah, a whole bunch of actor names over here with the film IDs, and there's not any of those like big duplicates like we had before. So it seems like we're making progress towards our answer. Are there any questions? So this was sort of like the key step for this problem is why this is the subquery right here that I'm checking the film ID of this query, seeing if it's inside this subquery. Yeah, sorry. Yeah, so the question is, could we have used a join statement instead of this in statement? And one of the things that we talked about earlier, maybe last week, is that anytime you have a join, any join statement can be replaced by an in statement, and most in statements can be replaced by a join statement. It turns out that the only time when a in statement cannot be replaced by a join is when there is a aggregate function like the sum or a count inside of the select over here. And so this can be replaced by a join clause. And after we get this fully working and tested, we will re-implement this problem using the join clause and seeing exactly what the difference is between the two. Any other questions about the problem so far? Okay, then let's go ahead and test our answer. We saw that the expected over here before doesn't have the film ID column, it's only the actor name, so let's go ahead and comment that out. I have a couple of different select queries in here, so I might want to use this one later for something else, so let's just comment it out, not delete it. Save that. Q up here, Control D, get out of pSQL, up arrow, replace that with bash, and let's try actually checking the answers. And it looks like everything is still failing for some reason. We've seen a number of ways to debug that, like what's going on with these failures. One is to manually look at the results side by side to see if you can see anything like with your naked eye about what's going on, about the difference. And when doing this, I strongly recommend doing it in the same tab, in the same Vim window. So again, it's :tab E opens up a new tab, and then GT cycles to the right, G♯T cycles to the left. And then you can sort of switch back and forth between these two things, seeing what exactly the difference is. And here, one of the things that I'm noticing is that the first three answers were the same. It's this third one down here that is not the same. And what's happening is we're actually getting some duplicates. The Albert Noltz is here twice. Looks like Audrey Bailey is as well, Cameron Streep. And so somehow we have to remove the duplicates from this select query. And I don't think we've actually in class talked about how to do that yet. There's a number of different ways that we can. Question? Yeah, so question is, could we group by? And that's sort of the most standard way to remove duplicates, is to do a group by, and then, there we go, actor name, like that. And if we rerun that, it looks like it's still not working yet, but now we've got the duplicates removed. So yeah, the first way of removing duplicates is with this group by clause.
A quick question. So sometimes I get the error like the not filter not by alias, right? So it appears like you don't have to do a subquery to get the actor name out. So in what cases can you not like filter on a alias?
Yeah, that's a good question. So up here, so again, whenever you have this as keyword in a column, the thing to the right over here is called the alias of this column, basically the name of this column. And the question is, when are you exactly allowed to reference this name in other part of the queries, and when are you not? But down here, I am referencing it and everything's working. But sometimes when you try to do that, you get problems. The answer is that the rules are complicated enough that I don't actually know all of them off the top of my head. I do know that if you have no, basically there are certain functions inside of the column list that if you include them, you're not allowed to use the column alias. The one that we've seen so far is the unnest function. If you're unnesting something, then you have to use the subquery in order to like group by or order by or reference that column alias. There are other functions as well that that you can't do that with, but as long as it's sort of some simple thing over here to the left of the as, then it works. And I don't know like the exact formal definition of simple in that case. Yeah, in practice, I just always kind of usually default to trying to use it, and if it doesn't work, then it doesn't work. One of the things, and so an even weirder thing, one of the things that you can do is you can refer to the column number in the group by and the order by sometimes when you cannot refer to the column alias. So I could say group by 1. Pretty sure this is still going to work. Come over here, edit, yeah, and you see there's no changes over here because there's only one column, so this is column number 1. When I say group by 1, it groups by this. Albert Nolt is therefore deduplicated. So sometimes that's an alternative to when this doesn't work, but that also does not work on the unnest function. Good questions. Any other questions so far? Julie? When can you not refer to the alias? So if you're using an unnest function, if up here, so there's no array up here, but if there were, and we did something like unnest, then you can't refer to it. You can always work around that by adding a subquery, and then you can refer to the columns of the subquery. Yeah, so it's, in practice for me, it's basically just a matter of trial and error. I try it, and then if it doesn't work, I add a subquery. Any other questions? Did you have your hand up?
Yeah, I was just wondering, can you remind us like whether you
Yeah, so question is down here a minute ago I had the 1 and a dash dash. The dash dash is a comment in SQL. So there's 2 ways to comment. The dash dash is a single line comment or a multi-line comment with a slash star starting it and star slash ending it like that. And then, so that's what the dash dash right here is saying, that ignore all of this stuff, ignore the column alias. And then the 1 right here is saying that instead of using a column alias or a column name, just go by column number, group by column number 1. You could also order by column number 1, 2, and that would be fine. Try not to do that, though. Usually it makes SQL code a lot more ugly because then you have to figure out exactly like what column up here it's referring to. But sometimes yeah, have been times when I've had to resort to that for whatever reason. Okay, so yeah, we're almost done. It seems like, so yeah, just pressing G capital T to switch back and forth between these windows. I don't see any immediately obvious differences. And so next thing I'll do is just look at the number of rows that they're both generating. On the right-hand side, the results, we have 112. On the left-hand side, 111. And we saw last time, or probably not last time, but not too long ago, that there's this diff command will tell us exactly what the difference between the two files is. We do expected /06.out and results /06.out. Then here's the answer. And the results, the one with one extra line, is returning Russell Bacall. The other one is not returning Russell Bacall. In 06, if we look over here, we have Russell Bacall right there. Over here, we only have Russell Temple. Right here, no Russell Bacall. And so we need to also remove Russell Bacall here. So we want this filter right here. And we also want another where clause where first name not equal Russell and last name is not equal to Bacall. And actually, I'm going to run this. I don't think it's going to work. I think my logic there is just a little bit off. I don't need a where clause right here. This syntax error up here is saying I don't need a where clause because I already have a where clause. This right here, this where clause should in fact be an and, something like that. Let's try that. It was still failing. And if we look at the results over here, now we see that there is no Russell at all anywhere in the output over here, no Russell at all in result 6. If I rerun my diff command like this, we'll see that this little arrow is pointing the other way now. It's that the expected used to have the Russell Temple inside of it, but the results has removed the Russell Temple. And the problem is just in my condition down here, very subtle difference between what I have and what I should have. YY, yank it, P to paste. I want and not first name equals Russell and last name equals Bacall. Slightly different meanings, this condition here and this condition here. This is the one that I actually want though, that I want the person. It's okay if somebody's first name is Russell, and it's okay if their last name is Russell as long as both of them together are not Russell and Bacall. So now save that up here. Check answers, run it. Oh, I have the and here. That should be commented out as well. Okay, and now it's passing. So this is our first complete solution to this problem number 6. And again, nothing too different than what we've seen before. It's just using this in clause with finding out the film IDs for what films Russell Bacall has acted in, and then joining that with an appropriate query up here to actually get his co-stars. I mentioned that, so what we'll do next is we'll see a couple alternative solutions to this, which depending on your thought processes might be easier or might not be easier, but still important to see. Any questions about this one before we go on to the alternative ways of implementing it? Question, Kieran?
I have a question about pagala-hw3 in general.
Sure.
I just like the due date. Since Sakai says it's due this Sunday, does it actually go a week?
If Sakai says it's due this Sunday, then that's incorrect. pagala-hw3 would be due this Sunday, homework 3 a week from this Sunday. Yeah, that's unfortunate that Sakai is that way, not easy to collaborate on. way back in the day, actually, before I came here, I had my own, I was teaching at UCR. I had my own implementation of Sakai that was based on Git. And so students could submit pull requests to change due dates and things. And if there was a mistake in my grading, you'd fix it with a pull request. But not using that anymore. We're using Sakai. Okay, so new way of solving this problem. Let's comment out this old solution, and there we go. So last time I started with sort of this query up here. Let's go add the order by as well. Oh, sorry, one last thing about the old solution that I don't think I mentioned. Intended to mention, told you I was going to mention, but I didn't mention it. We have the group by here to remove the distinct, or to deduplicate elements. Another way that you can make your elements unique and deduplicate them is just with the distinct clause up here by saying select distinct, and then you don't need the group by. The select distinct does the same thing as adding the group by of all of the different columns. Select distinct, not in the SQL standard, but it's basically supported by every SQL engine because it is just a lot more convenient than having to write out all of the column names, especially when you have many, many different columns. Okay, now we can comment out that. And let's go ahead, I'll copy that, paste it, and delete all this stuff. So we started off with our query last time with this first original query right here, where we were, let's keep the distinct in there. We had select, and then the first name and last name as actor names, and from actor, film actor using actor ID, order by actor name. And then we paused with this to go, we said that, okay, we're gonna have some sort of where clause based on this film ID. We paused, generated our subquery based on that film ID, seeing what film IDs Russell Bacall was in, and then we combine those two things back together. Our strategy this time will be a little bit different, using joins. So there's not gonna be a subquery down here. And in particular, this type of join we're going to use is called a self-join. A self-join is not a new type of join. It's actually any of the joins that we've seen before could sometimes be called a self-join. But a self-join just means you're joining the same table on the left and right hand side of the join operator. And so you could have self inner joins, left, right, full outer joins, and cross joins. Self just means the thing on the left, the table on the left and the right happen to be the same table. And inside of here, inside of our subquery down here, you can see that the tables that we have, film actor and actor, are the same as the tables that we have up here, actor and film actor. And so that's sort of the key, that when you convert this subquery into a join clause, you're going to be using this self join. In order to use a self join, I'm going to change my notation up here just a little bit, because with a self join, you cannot use the using clause. You must use the on and then explicitly specify your condition. And so we're going to change this so that it's no longer using the using clause. So on, and then actor.actor ID equals film actor.actor ID. And now what I'm going to do next is I'm going to join again on the film actor table. So join film actor on. And this join here, I want to have, let's see, so I'm gonna come back here. Our goal is to have all of the actors who are, have acted in a movie with Russell Bacall. So we're going from actor to film actor in order to get, well, basically we're just reproducing exactly what we have, down here. That we're selecting all of these things. The film actor and the actor are going to be in our the things that we're directly joining, but now it'll be the film ID that's the condition that we're actually joining on. So write it out on film actor dot actor ID equals film actor dot actor ID. This thing on the left of the equal sign over here, its intended meaning is to be this film ID on the left of the N right here. And the thing on the right, its intended meaning is to be this film ID right here from this subquery. So we saw a while back, changing the in clause into a join clause. The condition is this thing on the left is equal to this thing on the right. Here, both of these two things have the same name, and so there needs to be some way of disambiguating them. And previously, we've seen that you can disambiguate them by doing the film actor dot film ID. In this case, though, the table names are also have the same name, and so we have to disambiguate the table names. In order to disambiguate the table names, we'll do something like naming these table names. We'll call this one FA1 and this one FA2. This syntax of putting something immediately after the name of the table, we've seen this before in subqueries, that when you had a subquery, you put the name of what you want to refer to that subquery as immediately after it. This is entirely equivalent of saying film actor as FA2. Whoops, what button did I press? It's right here. So this up here, equivalent to this, just with a different name. The as down here is optional, and it's basically never used. So that's how we're going to do that. And then over here, when we're referring to the film actor tables, we have to specify which of these two film actor tables are we actually referring to. So first one, FA1, second one, FA2. And then up here, this film actor was referring to this one. So we'll replace that with FA1. We'll talk here in a little bit about conceptually wrapping our heads around exactly what's going on here. But the procedure that we've done so far has been a purely mechanical one. We're using the on clause to join a table with a subquery. And the thing in the condition of the on clause, again, is the thing on the left of the in is equal to the thing on the right of the in. And then we've just added some names in order to make those unambiguous what we're referring to. We have the film actor table that we just joined. So now we have to connect that again to the actor table down here. Join actor. And the condition we had was on, well, let's see, I'll delete that. DD for delete, come down here, I'll just copy it. YY for yank, yanks the whole line. Up here, P for pasting it. Pressing the less than sign twice shifts your indentation to the left. And so we join film actor on actor using the actor ID. Again, we can't use the using clause because it'll be ambiguous, so we'll change that to on. Fingers keep hitting the page up and page down button. So we change that to on, and now over here, we want, so it's the film actor 2 table that we were joining against. So FA2.actor ID equals this actor table dot actor ID. Again, we now have ambiguity about, I can't just put actor to the left of the dot right here. Can't just do actor right here because there's two tables over here. And so I have to specify which one of these tables I'll use. I'll call this one A2. For this one right here, A2. And I'll call this one up here A1 like that. And now up here, when I'm referring to actor, I should actually be referring to A1. So these 4 tables all joined together, just copied and pasted from the previous subquery, the previous query, where we had actor, 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 using this in, replacing this in with a join clause, and then providing all of these tables with aliases so that we don't get the ambiguity. That can look pretty scary, so if that looks scary, that's okay. But are there any questions that people have at this point?
So the logic here is like it's taking active names, figuring out the roles they were in, and then figuring out what.
So I'm going to pause you for a second. At this point, the way to think about generating this query is not about like, how do I generate it from scratch? Like, what is it doing? What is the semantics of this query? We'll talk about that in a second. At this point, you just want to think about like the mechanics of, given a query like this, converting it into the other one without getting into the semantics. So it's a good place for your mind to be going, but we'll hit the semantics after we finish this, and then we'll sort of talk about it from scratch from a strictly semantic perspective. So any questions about the sort of like mechanical conversion process?
I feel like, I don't know if this actually is, how do you like, only one, I would say two, like one SQL command with like also query to like 4.
So the question is, down here I have 4 tables joined together, whereas previously there was only one subquery. So where did those other joins come from? And the answer is that down here, I actually already had the joins. That this was from the original, so there's actor joined to film actor, and then this in, and then film actor joined to actor. And so I replaced this in with a join, but these other joins were already there. These joins that are already there, they could have also been written from as in clauses. So there could be like 4 different subqueries here that we could have rewritten this as, but we didn't. Okay, so the last sort of thing that we have to do to get this working is copying all of these where clauses back up to the top. So we'll start with, so this is inside the subquery. We have the first name and the last name. Copy those right here. Fix the indentation. And now it needs to know exactly which first name and which last name are we talking about, because there's 2 tables with first names and last names. And so here, these were from the subquery from the A2 table. So we'll do A2 dot first name and A2 dot last name. And then we also had a this condition right here in our where clause. So I'll copy in that. Move that one right here. This condition was outside of the subquery in the outer query. And so it was referring to the A1 actor table, A1 dot first name and A1 dot last name, like this. Last, final thing that needs to happen is that these first name and last name up here are ambiguous. We don't know which tables they're referring to. And these were in the outside query, not in the subquery. So they're referring to the A1 table. A1 table like that. And now I think if we run this, do the check answers, it should hopefully pass. It did not pass. Let's see what's wrong. We're getting no results. So that's not good. Let's go ahead and debug this by going into P-SQL. Let's see, do we get any results with just that query? We do, we get a lot of results. Okay, so something's wrong with our conditions somewhere. Let's try this one, just the A2 conditions. Run that. We get the actor name is Russell Bacall, and that's it. Check my solution here real quick to see. I think I just have a typo somewhere, and see if I can spot exactly what the typo is. I don't see what the typo is. We have A1, FA1, FA2, A2, A1, FA1, FA2, A2. FA1 dot actor ID. A1 dot actor ID. FA1 dot. This join right here is the where I messed up. I didn't copy things correctly from the previous solution here. So the two tables right here, these were from the subquery. These ones right here from the outer query. And if we take a look again at the condition on this in right here, it's the film ID that's being selected both times. Film ID to the left of the in, film ID is the column in the select. And so the film ID is the column that I should be joining on right here. But I'm not using film ID anywhere in this query. So that's a sign that we can't possibly be looking at who's actors with who if we're not even looking at films anywhere. And but this one should be film ID and film ID like that. Up there. Out of that, rerun it, and now it passes. So again, this condition right here comes from what the in clause was, and I just copied that over incorrectly using the wrong column. Okay, there were great questions before about like the semantics. How do we just interpret this by itself without looking back at the subquery version? And we'll start talking about that next. But are there any questions about maybe the query as it is before we talk about the semantic things? Any other notational things? Yeah. So
do we use like or what was the section about self-join?
So question is how, like, where exactly is the self join happening? And the answer is that these two tables are getting self joined together. Film actor joined on film actor. Because it's the same table appearing twice in this list of joins that makes it a self join. So yeah, like that procedure that we were using is the same procedure that we saw before when we first talked about the in clause and how it relates to joins. But because it was a self join, we had to do this. We had to name all these tables so that we knew exactly here that we're checking fa1.filmid compared to fa2.filmid. So when you're using the self join, you're going to have to name all of your tables like this, give them the aliases. Did that answer your question?
So it's not like a special syntax.
Good question. So yeah, no special syntax for a self join. And it's not even like, let's see, so like people would think of as an inner join as something distinct, like a separate concept as a left join, outer join, right join, full join. Self join is just sort of like a colloquial name for something that happens to have the same table on the left and right, but it's not a different type of join. Good questions. Any other questions so far? Okay. Yeah, so semantically, how would you come up with like something like this on your own? And I don't know, for me, at this point in my sort of SQL programming career, it's easier for me to generate this directly than it is for me to go through through this process and generate this query. The top one just feels more natural, and most people, I think, who have been working with SQL for a while would find this sort of self-join strategy more natural than the other way. But let's try to talk a little bit about how to make that the case. And maybe actually before doing that, I'll say that for like any of your assignments and midterm, there's never going to be a time where you will have to use like one of these versus the other. In pagala-hw3, I made you at one point use the not in operator and the left join on the same problem just to get experience with both of those. With the self join, I'm not going to require that. You're free to use whatever technique you want that makes sense to you whenever it makes sense to you. Yeah, so typically when I'm working on, so when I'm working on these sort of problems, I basically am always starting from like thinking about things from top to bottom. The reason that these things are ordered the way they are after I'm done writing a problem is because I started thinking about the actor table, then went film actor, and then back to actor, thinking about it at each step. When I am thinking about this, so I have an actor, I need to know what films the actor has been in. And so joining actor in the film actor column tells me what films the actor has been in. And then I want to know what other films that actor has been in, or actors related to that film. And that's where this join right here comes in. That if we had only something that looked like select star from film actor, let's copy these. Film actor FA1. There's no join here. So if we're only joining the two film actor tables together, sort of like the heart of the self-join part, then what this is doing is it's asking for like, what are all the pairs of actors that have appeared together in any film? So film actor has an actor ID and a film ID. If we make the film ID the same, sort of cross product these two tables together and set film ID to be the same, filter on the film ID, then the thing that's left is two different actor IDs where the films have been the same. So it gets us all of the actors who have been in the same film together. If we look at the bipartite graph right here, so here the blue, and this is really faint on the screen. Maybe if I zoom in a little bit, it'll be easier to see. The blue is the film actor table. When I'm doing a join, on the film actor table, it's like looking at the blue and then connecting it to the other blues. So it's all the length 2 joins, all the length 2 paths is the result of that join. Yeah, I don't know that there's a better semantic explanation for that, but that's what that is. Hopefully that maybe made a little bit of sense. If not, it's the mechanics of going through it again with the subquery and converting it back like this. Any other questions about this problem? Sorry?
The software also sort of like active by itself, you know, for all the movies that the actor is in. Like actor. Oh
yeah. So yeah, question is, so with the self join right here, do we get actors with themselves? And the answer is yes. So this is just a cross product between the film actor table with itself. And so in the cross product, you get all the different possible combinations. And so one of those combinations is going to be with an actor with themselves. Run this. So here we only have actor IDs. We don't have the actor names. But if we look down here, we get the actor ID. Actor ID is 1 in both cases. And it's that particular thing that's caused us to have to do this extra filtering right here, that because Russell Bacall is in this cross product with himself, then we do the filtering to remove him right here because Russell Bacall has a Bacall number of 0, and we only wanted people with a Bacall number of 1. Did that answer your question?
Why do we do like the second one on the actor thing? Like, why can't you just do the like get the actor names from the first actor?
So the question is here, why do we need 2 joins on the actor table? And the answer is because we have 2 different actor ID columns. When you're doing the join, you can only make the join sort of happen once. That with this join right here, this first join on the actor A1, what I'm doing is taking this actor ID and replacing it with the names. So it's from actor A1, join on, let's just copy it like that. So only one of the joins, put that in. Now there's a lot more columns, but now you can see that here's the one actor ID, Penelope Guinness, and it did not replace this film ID column over here, or sorry, actor ID column. It's got these ones, but not this actor ID over here. And so in order to get the second actor, we need that second join, which will be on this actor ID column. For the, let's see, the remainder of the problems 5, 6, 7, and 8 are all somehow using the same sort of technique right here. The problem 7 is the most closely related to this one right here. Well, let's see. Start with problem 5. Problem 5, you're joining all of these same tables together. The only difference, so you're still using the film actor tables as, if you're using it with the self joins, film actor tables. You'll just have the film table in these outer ones here and different where clauses. Problem 7. Is asking for a Bacall number of 2 instead of a Bacall number of 1. And the easiest way to do that, the way that I think is the most natural, is if we rewrite these 2 queries. I'm going to rewrite this part of the where clause in just a subtle way, saying that so and A2 dot actor ID is in select actor ID from actor where A2 dot first name equals Russell and A2 dot last name equals Bacall. So these 2 conditions right here is the same as this condition right here. They'll give you the same exact results. These the stuff in the where clause right here is exactly the same. And we're getting the actor ID and just making it exactly equal to the actor ID. And then down here, and A1 dot actor ID not in. So exact same thing. as this. This bottommost condition, exactly the same as this top condition. They mean the same exact thing. The reason I wrote it this way, though, is that here we can think of this as sort of all of the actors who have a call number of 0. And because we're doing the filtering on the actors with the call number of 0, we get the actors with the call number of 1. If we change this query right here, change this to be the query of actors with the call number 1, then this query, this outer query, will give us the actual results of who has the call number 2. And that's what problem number 7 is asking you for. So that's what my solution looks like. It looks exactly like this, but these subqueries right here are, instead of this small subquery, it's this giant subquery right here. Because both of these two queries are exactly the same, it would be a huge pain in the butt to write them multiple times. And so SQL has something called a common table subexpression. It doesn't add any power to the SQL language. So CTE equals common table subexpression. But it's basically like a variable for a table, being able to assign a name and then use it in multiple locations. The idea is you say with, and then I'll call it, so in this case, it's call 0 as this whole thing, like that. Select star from the call 0. So this right here gives me all the results from this table up here. And now I don't have to have that subquery repeated multiple times. And so my solution for the number 7, what it looks like is just this with the thing inside of here being the query for the people with the call number of 1 instead of with the call number of 0. Thanks. Well, let's see. Any questions about the syntax of the common table expression or what the common table expression is? Not something you need to know, but something that's useful. It's just with the name of your table as this, and then you can use this table name however you would like down here, anywhere we could use an ordinary table name. So like in the to the right of a from statement. Okay. Then we'll stop class a little bit early for today. Happy to answer questions that people have after class about this or about anything else. And I hope you all have a great weekend.